Welcome to Math Essential Coordinate System. In this video, we'll discuss the transformation between a Cartesian and spherical system. So as we have learned in the previous videos, we need to do two things. One, to relate the dimensions to each other. Then we relate the unit vectors. To do so, we can look to the geometry. We have our r is here. This is our x. This is our y. And this is our z. Let's move z here. It is the same dimension z, which is perpendicular to the xy plane. And if we remind each other, we know that this one is actually rho from the cylindrical coordinates. Now let's find the angle. We know that r and z contain theta, and actually if you look carefully to geometry, you'll find this also theta. Now let's move this geometry here. We have z, we have rho from the cylindrical coordinates, and we have here our r, and we have here theta. Now we can calculate rho is just equal to r sine theta. Another thing we can get from here that r square is actually equal to z square plus rho square. The third thing which we can get from this geometry is that z is equal to r cosine theta. Now we have solved the first mystery here. This one done. Now let's take the first equation, this equation 1 here, and we know that rho is equal to x square plus y square. Of course, rho square, not just rho. We also know from cylindrical coordinate that x is equal to rho cosine phi in this case, and y is equal to rho sine phi. Just for your memory, this is actually our angle phi, so you can repeat the previous video and understand how exactly this relation come from. So we can use now our equation number 1, which we have stated. Just x is equal to here rho replaced by r sine theta, multiply again by r cosine phi. Similarly, y is equal to r sine theta, then multiply by sine phi. These ones solve the second mystery and third mystery here. Now let's use the number 2 here. So we have r square equal to z square plus rho square, which is actually x square plus y square. And if you reformulate this one, you can reach r equal to the root square of x square plus y square plus z square. So one more mystery has been solved. The remaining two angles, one we already used before to determine it, equation number 3. So this one simply we do again here. Just you take cosine theta equal to z over r, then you make cosine minus 1 of the two sides, then you get the other mystery here. Finally, this one we have done in the cylindrical coordinate, but we can redo simply these two equations. So we divide these two equations by each other. You find y over x equal to rho sine phi divided by rho cosine phi. So rho cancel with rho. Then you are left with sine over cosine, which is simply tan phi equal to y over x. So this one, if you take tan minus 1 both sides, you will get that phi is equal to tan minus 1 y over x. Now we move to unit vectors relations, and as we have studied, these values here are simply the dot product between each two vectors. So r dot I is simply this value, and so on. Since this 3D is better first to convert to 2D projection, then we do the 3D projection. So let's plot the unit vectors. We have R and we have rho and we have K, which represent Z. From where it comes, simply if you look here, this is our R and this one is rho, so you can replot here, and K is this one. Between K and R we have the angle theta, and in the same direction you can have perpendicular here to R, which is simply your theta. The question will come why I'm doing rho here. Simply because we already have the projection of rho in I and J, and simply if we got projection of R and theta on rho, we can then make another projection of rho in I and J to get the final value. I mean the relation between R and J and I. So the final relation which we want to get is rho dot theta here, rho dot theta, which is simply equal to cosine theta. We know that rho dot I equal to cosine phi, and rho dot j equal to sine phi. With these two equations, we can bring first, for example, rho dot r. So simply, you can say r dot I equal to the term which you bring first, sine theta. This was the projection of r on rho. Then you have another projection which is rho on I. Then you bring the cosine phi. Similarly, you can have r dot j equal to sine theta, the projection of r on rho, multiplied by sine phi. Likewise, you can use the relation, this one, rho dot theta equal to cosine theta, also these two equations, to find theta dot I, which will equal to cosine theta from here will bring, and cosine phi from here. And finally, theta dot j equal to cosine theta again, multiplied by sine phi. You can, build the matrix back using these dot products which we have found. So, for example, say I and theta. So I want this row and this column. So simply it is this one, cosine theta, cosine phi, and yeah, this is correct. So what we have done, we have found intermediate plan which consists of r, rho, theta, and k. Then from prior knowledge, we from the cylindrical coordinate, the relation between rho and ij, we could transfer projections which we have found to projections on I and J. So in summary, we have related the dimensions and unit vectors of the Cartesian and spherical coordinates. Thank you.